streaming analytics. In that, we'll discuss about comparing big data and edge analytics. Then we have edge analytics core functions. We'll discuss afterwards. Then distributed analytics systems. And the last heading of this chapter is network analytics, that I'll discuss also. We will complete these two headings today, and we'll start new chapter from the next class itself. So we'll take a heading called edge streaming analytics. So in the world of IoT, vast quantities of data are generated that we know already. Okay, so generate on the fly, because as you go on, as the things starts moving or flying anywhere, they generate a huge amount of data that already we are aware of it, and often need to be analyzed and responded to immediately. Most important thing is that you use a number of sensors, and definitely they do generate more number of data, and what we need to do with the more number of data, huge data, that should be analyzed. After analysis, that should be responded back. Whatever can be the outcome or action, that should be happen automatically. See, not only the volume of data generated at the edge, that means the particular node it generates, the bandwidth requirements to the cloud or data center need to be engineered to match. Even we are facing currently with the Microsoft Teams app, since it requires high bandwidth, and some of you are able to connect, some of you are not, even some of you are facing a problem because of bandwidth problem only, bandwidth requirements. Maybe the network cell near you or around you might be it's having a less strength, or which it could not take enough bandwidth to transmit the data over internet. So that might be another reason. So as the huge data which we are generating, and we have to bother about bandwidth requirements at the cloud, or we call it the data center. So the data may be so no, it's a time sensitive that needs to immediate attention and waiting for a deep analysis in the cloud. That means you are generating a huge data. It's in terms of petabyte or more than that. No, like it's a huge data. So when the data is generating more and more, so what we need to worry about here is time sensitive. That means immediate action has to take place by the cloud or a data center. For that we need a deep analysis in the cloud. Actually, it is very difficult. Simply, it's not possible to happen. For that we use some techniques that we discuss now. That's big data and edge analytics. We need to compare these two. Big data, which stores any volume of data. So from that any volume of data, we need to analyze the data. So that we use edge analytics. So the key values of edge streaming analytics, so it includes first one is reducing data at the edge. That means at a particular node we try to reduce the data which is going to be generated. That means the aggregate data generated by IoT devices is generally in proportion to the number of devices. Obviously, you have a 10 multiplied by 10 only, you will be getting a data. If you have 100 multiplied by 100 only, and the scale of these devices is likely to be huge, and so is the quantity of data is also be generated more. Definitely, passing all this data to the cloud is inefficient and unnecessarily expensive in terms of bandwidth and network infrastructure. Obviously, if you want to attend 3 classes or a class of 2 hours continuously or 3 hours continuously, definitely this Microsoft Teams app requires more bandwidth, and definitely it consumes more data, definitely, and you need to invest more for that. That's expensive. It will become more expensive. Okay, and as you are going to use a cloud, the cloud becomes inefficient as you unnecessarily pass more number of data over a cloud also. So that's the first point, reducing the data at the edge, which what it includes in the edge streaming analytics. Second point in the edge analytics includes is analysis and response at the edge. As I told you already, edge simply it contains the more data, and we need to analyze. Okay, so some data is useful only at the edge, so we use some data. So like a factory control feedback system, some we require, not all the data. So why you are going to keep all the data? So analyze it and respond it back. In cases such as this, the data is best analyzed and acted upon where it is generated. You should take immediate action as you are getting more number of data. Simply do not keep more number of data in the edges. Third point which we need to include in the edge analytics is time sensitivity. As I already used the word in the first point, timely response to the data required or passing data to the cloud for future processing results in unacceptable latency. That means there might be a chances of producing a delay if you are not responding on time, called as a timely response. If it is not there, the delay can be or latency can be increased. If the latency is increased, definitely the efficiency, throughput and all those things will be again affecting a lot. So this edge analytics allows immediate response to the changing conditions. That's why we use this edge analytics. So we see some of the core functions of this edge analytics. So it's used to perform analytics at the edge. Data needs to be viewed as a real-time flows. That's why we use edge analytics. You got it? Edge is a particular node where a huge data is generated. We need to bother about some of the points. Now we have to think about some of the core functions. That first you need to data should be viewed as what? Real-time flows, where the big data analytics is focused on large quantities of data at rest, because big data is mainly it holds the data at rest. Edge analytics continually process streaming flows of data in motion. That means data is not here going to rest. I mean, data is not going to store. So data is flowing and you're only analyzing it. So you're not going to store the data at the particular edge. It's not a something like that. This streaming analytics, what we use in the edge, it can be broken into three simple stages, which we are breaking streaming analytics. First stage is raw input data. Second is analytics processing unit called APU, and third is output streams. We'll see one by one now. The raw input data which we use, the first stage. So here the raw data coming from the sensors. Obviously raw data comes from sensors only. Ultimately you are getting from that only. So the sensors into the next process we have to supply called APU, that is analytics processing unit. So each definitely this APU it processes the data which we have taken from the sensors. So what it does, it filters and combines data streams, organizes them by time windows and performs various analytical functions. APU does this. It is at this point that the results may be acted on by microservices running in the APU. That means you will be having some results based on what microservices you are running. Based on that it produces. Okay. And the third stage of this edge analytics is output streams, because we have taken raw data from raw input data and we processed here using APU, and we need to produce the output now here. So the data that is output is organized into insightful streams and is used to influence the behavior smart objects and passed on for storage and further processing in the cloud. So it also does communication with the cloud, often happens through a standard publisher or subscriber messaging protocol such as MQTT.